Hey, hi. Actually, I was doing this question, balance binary. I couldn't actually get the question quite right. Uh, First, I'll explain my solution, what I was trying to do, and I made it quite complex in the process. So, I was trying to do this BFS over it. And I guess BFS. I'll ask GPT just about now, like if BFS is possible or not. But I was trying to do BFS. I know where the complexity lies now. I was using two variables, min and max, to get the height of the tree. Like I was thinking, uh, if I visited this node, right, and I'm not able to go any further from here, then just give me a second. Yeah, any further from here, so I'll get this height, and if it is 1 2 3 whatever, then I'll keep the right hand side height, right? So um, I guess while returning or while popping it out, that is why DFS is working better, I believe, because while returning we are adding the height up, not while traversing. So So if what I was doing, I was pushing things in the queue, and if if the node is a leaf node, then I was taking care of small and big. Uh, I give S and B, so it's least height and most height I was tracking. So given a node 9, right? So I'll show you here. Suppose in this case, this first one, right? So given a node 3, this is not a leaf node obviously, so SNB is not calculated. The value of SNB is respectively this, and now at 20 was pushed and 9 was pushed. So after 20, 15 and 7 was pushed, 7 and 15, right? So we popped 20, and that next one was 9, right? I mean, not pop, DQ'd, and next one was 9. So 9 came, as 9 is a leaf node. So when we push 9 na, we pushed it with last value plus 1. So this time what we got, uh, height of it, right? So we are checking what is the like one leaf node's height we got in our hand, right? So we are keeping it in the small and big while checking if it is eligible to come in small or big or not, right? So we made these comparisons, and now small is 1 and big is 1, and now we know like small is not never going to upgrade from 1, right? uh, Else we get any 0 here. Okay, so yeah, now next we get to this 20, and okay, we already got to 20. Now we got to this 7. So see, when we push 20, right, I mean when we pushed 7, so we got the third or second of 20, that was already 1, then plus 1, and we pushed 7, right? Got my point? So now when we popped it back, we got 2, right? We got 2 as the height. So max will update, right? Last max was 1, now is 2. Now we got till node 15, and now we are getting this. So it worked here. It worked at many test cases, different and complex test cases. I'll show you this as in the, you say, tree form, right? So this worked, then this also worked, right? And this also worked, this also worked, and this also worked. But what didn't work is this one. Uh, this one. Let me use this test case, and let's go back in description, in code. Let's run it. So this was a skew tree. In such case, what I did is I calculated the max width of q, right, and checked if it is equals to the height plus 1. then I determined the tree can only be a skew tree in that case, and I'm returning false. Okay, and I'm checking. Suppose there's only one node. Okay, got the idea why it is returning false. I should also put and s should be greater than s should be greater than 1, right? So maybe now at this time this will work. I don't know how many cases will I apply. I think this will fail at some point again. Let's see. Yeah, I knew it. It will fail. So let's use this test case. This is both sides skew, and let's run it. Output is given as true, expected as false. I'm giving it as true, but expected was false. Let's see the code. So here, what is the problem? Output is std out is 7. Let me do this. Now let's run. Right now I'm trying to make my solution correct. Like I have put a lot of work, right? So so again, I guess the only thing which is missing is left tree and right tree consideration. Left subtree and right subtree of a subtree or a entire tree. As let's see, as this is a skew, right, on both sides. So what is happening? As this is a skew on both sides, so it is not keeping like I'm only calculating this min and max, right? When it is a leaf node, and this is a leaf node only at 4, and when we reached 4 I have already pushed 1 right, 1 till 4 and 1 till 4 here, right? So now I mean 3, so that is what we are getting test result. You can see that 4 3 is there and that 4 3 is there, so that's the part which is missing. That's the last case, I guess, and if I solve it properly, I guess this in this case will also get solved, will get solved in that. Okay, I'll ask GPT. I have asked GPT. It has given me first as DFS solution, which I'm not interested right now to check out, and other one is which I have asked for an iterative approach. Other one is this, still a DFS approach, because right now it is using stack, right? So similar. I can ask like I can ask him, can you do it using BFS? Alright, so it is using map to store height of each node in this solution. Int left height if node of left exists, height map node left, or else 0. Process children enrolled and calculate their heights. Left height equals node left and height map um, means it is trying to see if node left exists, then the left head should be this or 0, in this case, or 0. And for that node we are updating the height, max of left height comma right height plus 1. And what I'm thinking is, given map, right, we have nodes, and each node is going to be unique. That is correct. But how come we are going to visit the same node again if we are doing this level order traversal? Why are we? Okay, let's try to understand. If node has children, their neighbors are fetched from the map. Let's see if this is a correct solution or not. Let me try it. Command A, Command V. Let me run it. Yep, not a right solution. I mean, yeah, I guess this is pretty much apparent why it will work, right? In okay, skew cases are failing, as well as what is this tree? This is also kind of skew tree, so it is actually failing in many cases. My code was a little better than this then. Let's run it. Yeah. So okay, GPT code is bullshit in this case. I'll check on the internet, or I can check the solutions right here, right in this one. Bottom of solution would be better. Python iterative and recursive. Okay. So if root, okay, this is a DFS solution. I believe I understood this one. So if root is null, we are returning 0, and 0 means what? That is 0 means false, right? Yeah, we're returning 0. And if answer, okay, we are we are keeping an universal pointer, and sure, we are returning 0. We are saying if answer is false, right, then we are returning 0. So answer should be true at all the times. This is what it is trying to say. And I mean, we could have returned here itself, right? Whatever. So return 1 plus max of left subtree comma right subtree. Return 1 plus max of left subtree comma right subtree. Yeah, this is the height which we are calculating from this one and this one. And we are checking the balance of left and right. So Suppose this one is null, it returns 0 in that case, right? And this gets 0. And I'll need to do it on the tablet. I'll do this on tablet. Then I'll need some space to write it on, and let's do this. Let's look at an iterative solution. Can I just search for BFS shamelessly? BFS. Alright, I think there's no solution of BFS in this one. So need to check why there's no BFS. Okay, as well as why there's no BFS, as well as what how the DFS solution is working. Okay, so yeah, I need this DFS solution. I'll paste it. Solutions. Remove this one. Votes. Most votes. Let's see this one. I'll use this code. I'll just take a screenshot. Wait. We'll discuss this one. And I'm pasting it in my tablet. And I want to remove the comments, I believe. Why? Because alright. Let me stop the screen recording. So yeah, guys. Hi to myself. I analyzed the solution, got the point, got the array structure, and like for me as well now I'm little bit refined how I need to understand the stack structure, stack behavior of the function. So yeah, I'll edit this time because or maybe I'll not edit. I'll put the part where I struggled and put the part where I thought of this refined approach. Like this is not super refined, but for the time being it got refined. So yeah, first analysis video, that 18 minute. After this one where I do making the solution, like typing out the solution, then after that I'll put the analysis of this solution which helped me to understand the solution. So yeah, I'll add it to the last. So in the last part, if you see the tablet, and this is a message to myself as well, for the future. If last part you see the tablet video and you want to skip the things, you can skip it because there's better explanation in the later quarter of the video, you can say. Yeah, so let me type out the solution. So this solution was okay, and also I didn't found out like why this. I actually found out like why BFS is not a very good idea to apply. Maybe there's a solution which is present using BFS. Right now, I don't want to analyze too much. I'll do it. I'll do each and everything. That is for sure. But I need to get to another level at least for now. So I'm not going to do very deep analysis. I'm already doing the analysis. So for now, what I think is I'm not able to track left subtree and right subtree at once. Okay, so skew trees are giving me the problem. This solution was fine, but the skew thing was giving me the problem. So right now I'll just skip this. Yeah, I'll type out the solution. Now return balance root not equals to -1, and we'll do integer of what? Integer of val and 3 node star root, and we'll start here. If root return 0 means if root is not true, means if the given node is null, then return 0 means there's no height 0. Got my point? Yeah. Now after returning 0, we'll try to gather the left height. Int left height equals we'll iterate to the left part of the root. So val of root left, and similarly we will do for the right side. Int right height equals val of root right. Okay, now we need to check. First we need to do this thing. We need to calculate if left height minus right height. Okay, if in absolute of left height minus right height is greater than 1, okay, we will be returning -1, and we will be returning -1, and yeah, if there's a height difference, okay, so we are directly returning -1, and if the root is by default null, we are also returning -1, and I'll see, just give me some seconds. We can do return max of, so we are increasing height by 1 each time. Left height comma right height. So right now I still feel like I'm just doing the memorization of the solution, but it is not in that way. When you see my explanation of this, like analysis of this problem, I need to do such analysis little more. Some more problem I need to see. Then I'll able to better grasp this conditions, and like there needs a circuit in my brain to get the solution of recursive problems correctly, so that I would be able to do the final boss, the DP questions. Yeah, I want to become fluent actually, at least in these things. Let's see if I run it, how it is going to go. Okay, in the case number 7 we are getting wrong result, and case number 7 is what? Maybe both sides q. So yeah, let me check. If left height, okay, if you are returning this -1, right, and you are maybe that might get lost in this one. See, this -1 is not like rigorous, like it will, if you analyze the flow, this -1 is not getting used properly right now. Okay, even if, see, suppose, let's comment it out. I believe this should happen, otherwise I need to do a little more analysis. And let's just run this one. So we are getting more cases wrong. Okay, so I guess all of them are skew ones only. So yeah, after removing that case, we are getting more skew ones as wrong. So yeah, so I believe this one, what it is doing is, if it is a 2, 5 and 7, these trees are kind of skew trees. So you see, 2 is like this. It is both left trees, and both in the in both side, left side is going to be higher side, okay, and right side is going to be on the at the end, if this one is enabled, okay, so at the end this is going to cancel out each other. Oh my god, I want to analyze these things. Okay, I do not want to make 10,000 videos and 30,000 videos. I'll analyze it without making a video. Right now, need to analyze our skews. Let's see if I have uncommented this. How well this one is working. Okay, so this final skew case is not working. Skew trees case is not working. This one. Let's see. Let's do it. If left height equals -1, return. This is, I'm just looking from the solution. Till now I haven't looked. Just now finally I'm looking. If right height equals -1, return -1. Okay, so what is the comment for this line? This line I'll read it. Okay, just give me some time. Now let me submit it. Yeah, this worked fine. Yeah, now let me read out the comments. What are the comments along with these lines? So this line I need to analyze. It is saying, for this line it is saying, if the left subtree height is unbalanced, return -1, and this is saying if right subtree height is unbalanced, return -1. And that what I believe is rightfully so, this will be the height of right subtree and this will be the height of left subtree. Like it is a sub problem of the left subtree from here on. Okay, so from here on we are tackling the problem of left subtree. Suppose this is a given problem, and let's check the test case. Good test case, good one, which is good one. There's no good test case to show. Okay, yeah, this one. So yeah, this is going to be obviously false, but suppose this 8 is not there. So when we go to 2, okay, so this one this call is same as this call. You can see this call, because it is computing the solution for the entire left subtree from here on. And similarly, this call is same as again this call, because it is computing the entire solution of this one. And if we are ignoring the if the left subtree itself is not balanced, and we are directly trying to compare with the right subtree, okay, so we are definitely going to get the positive outcome. Okay, so I mean so in some instances, suppose when I commented this out, so we got all these Q things wrong, right? So what is actually happening is, at some point we are not we are not suppose it is there, okay, and at case number 7 was failing. It passed only because I have added these two lines. Okay, so the case number 7 was failing because this line was removed. These two lines were added. So how this line was not protecting case number 7 as well? Why? Because we are not checking the individual subtrees. Okay, we are not checking the individual subtrees. So it was passing on that one. That is fine. But when we come to 1, okay, or we check like what is the height of this left subtree or right subtree. Let me just run it. Okay, now let me just comment this out. Not checking left and right subtree individually for the answer, and this one is failing. Yeah. So finally, what we can do is pop. So obviously left and right height is getting propagated till end. So before doing this math, what if so yeah, see this was expected as false, we are getting true. Let me just print it out here. See out left Gij height right Gij height, and let me just run this. So at case number 7 we are getting -1 and -1, and max will be 1, and we will be getting 0 at the end. So that is why it is getting us true. So that's it, why we are getting the answer as true. Now since see this is -1, right, and this is 0 1 0 1 1. So how this is going to perform is, first statement will be last statement will be the last answer, first statement will be the first answer, because it is in stack. So this -1 and -1 after +1 is getting cancelled out. That is why the answer is coming as like whatever it is coming. Yeah, true. It is coming true. So now I need to think about it a little more. uh, 0 0 1 0. One more thing, just move any boundages in your mind, like what people is going to think. You are taking so much time, you are not a fucking YouTuber, you are doing this for yourself. Just keep that in mind. Yeah, now let's continue. So 0 0 1 0 0 oh my god. Okay. At last it is 0 0, and at beginning it was -1 and why it was -1, that we need to think. Because of this one only it can be -1, because the height difference was not height difference, what you say, was not what you wanted actually. So let me put it up here. Maybe the output will change, and let's print it out. See, so 2 is there, and at last we got -1 because at least it will run one time, then it will come. Yeah, so 0, left subtree is running, left subtree is running, right subtree is there, just looking at your face, because left subtree means left subtree is there, right subtree is just null each time. You go back to the root. Now at this point you are back at root. Okay, and back at root you are this is right subtree starting from here, I believe. Yeah, this one is left subtree and this one is right subtree, and you can clearly see it only fails. Yeah, now I get it. It only fails here and here. Okay, it fails here and here, but if you do it individually you will ultimately get 2 and 2, 2 and 2. Okay, we got two -1s, that is left height and right height, and we are still going to do this left height comma right height +1. Excuse me, I'm sorry, I need some time.
Yeah, hi, back on the tablet. So let's see how this code is working. So let's take an example from the LeetCode itself. Let's work with the first one, which is true. So 3 9 20 15 and 7. So now I'll make a stack and shit. So now let's see 3 9 20 15 and 7 is that right? So we'll start with this line. It is sending the root node, that is tree, here, and it is checking if it is not -1, then it is returning hi tree node, and if node is null pointer, return 0. so not returning. If int left height equals, so we are checking the height of left subtree. I mean, we are checking the height of left subtree, that is this. So left subtree height, so this will go, we'll do int left height equals stack is here, okay, and we have called this left height, so we have called the height function. First function which is being called is height with 3. Next function is called height with 9. The next function which is called is neither this nor that, so left height, it will try to check the left height, right? And we have called the height function itself with 9, node 9. So again, after calling it with 9, we'll be getting this, it's left, we will be calling height with null and another into 2 times null and null, so both time returns 0, and left height, that means left height gets 0, left height gets 0 equals 0, this comes back as 0, and now we are at this point. I'm not able to make this stacks properly actually. I need to get an idea like how to make the stacks properly. So yeah, the height 3 function which we have called with root, right? So it is still there. 9 will pop. You're getting my point. Why? Because we have already done the left and right side of it, right? So left side is done. First of all, left side is done. Next thing that is remaining is its right side. So left height is 0, we are propagating, but here when we call next again, so igst right height also equals 0 here. So now this is already popped, so there's no meaning in this one. So at 9 this function is also popped. We are at 3, and left height we have as 0 right now. So left height, right height plus 1. Okay, I'm not able to make this stack thing properly. I'll redo it. I need to figure out how to make it properly. Maybe I'll do line numbers. Let me put out line numbers here. Line number 1, line number 2, line number 3, 4, 5, 6, 7, 8. So we have 8 lines, and now we are calling from line number 1 is called. So when the line number 1 is called, we have called height with 3, right? So after calling height with 3, the stack is there, line number 1 we have called, and this, suppose this is the stack. Next function, next function next function which is called is at line number, next function which I have called is at line number 2, and not a function, actually line executable code. So called at 2, and 2 is doing nothing. So we go to 3, and at 3 are we going to do anything? Yes, we are calling its left subtree. So at line number 3 we are calling its left subtree, and we are calling gist height again of 9. Okay, so you have called it with 9, and this is not null pointer, so this is fine. So again we will call line number 3 and height of null. We will getting 0 as a return here. So we will propagate back a 0 here in this one, in this case, and this is popped. So this stack space is empty, and I can say this is left height. I mean, I can also mention it 0. And right now, next as this has returned at line number 3, so we will continue with line number 4, correct? So at line number 4 we are currently, and line number 4, I mean, this is on the same call, right? Still, so we are actually not even using the same sex stack space, this one, and we are now at line number 4. And line number 4, I mean, this should, I'll write it properly, left height, this is giving this, and going back to line number 4. Yeah, so line number 4 is not working properly. Then we are calling line number 4 will be calling height of null again, because right is null, right? So we will get whatever, so height of left, right? So this is 4, and we'll be getting right height, right? Gst right height as at line number 4, not 4, it came back at 4. This will pop and also return 0. It will call this one here, and line number 4 was there, that is full. Line number 4 it called back, and this is line number 5, right? Line number 5, and it called back here, right height is 0. This one is done for. Now we are at next stack. like this continues. So line number 5, now we are at line number 6. That passes. 5 passes, 4 passes, 3 4 5 6. 6 is doing nothing. Line number 7 is absolute difference between left and right is greater than 1, but this is 0 minus 0 is greater than 1. No, line number 7 0 minus 0. So we return line number 8, that is 1. So it returns 1 at last. So we go back here, and at height 3, whatever we called, so we get answer here left. This gets popped. Okay, so this gets popped here, and it gives left ft gi gst height equals 1. Now we are going to do the right subtree for this one, and right subtree will be similarly, we will be putting 20 there. Now I mean the same stack space we are going to do, right? So I mean we are at line number 1, and now 2 is done. I mean 3 is already done. Okay, so we are at line number 4. Line number 4, and this doesn't work. Line number 5. So line number 5 once again in with right subtree now. So now it is being called to right subtree, and yeah, we'll be using this one, and right subtree will come here, and at this point we'll be doing height of 20, and height of 20 will be again height of 20 will give nothing but next height gst height of 15, because left subtree and all right, and height of 15, and the left subtree value here. What will be the left subtree value here? As it will give null pointer and 0, so left subtree value will be height left subtree barabar 0, and this pops, and next one is height 7, and this will also give right subtree barabar 0. At the end, height 20 at line 8, it will return at line 8, it will return 0 plus max of 0 comma 0 plus 1, that is 1. So for 20, you understanding, right? We are 20, and we have already 20. For 15, I have got 0 0. So height is 1. at 20 we are collecting answer as 0 and 0. So we are at, suppose we are 20 and we call the left subtree. Let me remove it and do it again. So see, my explanation is going to be horseshit if you're going to look at this text. Okay, so maybe with time I will improve, and I need to watch some videos of my previous teacher, so I'll get better idea how to write down these things. So height 20 is there, and height 20. Wait, height 20. So I'll call height 15. As soon as I call height 15, so height 20 is already right one. Okay, so when I call height 15, this means answer as 0 because it doesn't terminate at end, and this will also, I mean at line 2 itself it will terminate, and this will at 2 line 2 and line 2 it will terminate as both are leaf node. Like, yeah, because I mean for 15 you will do it 2 times, right? So for 15 you will get so 15 you will make 2 calls obviously, so each time you will get 0 and 0, and yeah, each time you will get 0 and 0, and so your left height is going to be 1. Left height when ends 1 because of a similar process, and right height, so it's also going to be 1. So we got this 1 and 1, and at the end of it will be 1, it will be 1 comma 1. Okay, it will be 1 comma 1, and 1 comma 1 plus 1, that will be equals to 2, and I mean, why I'm so confused here? I have everything. I have a tablet, I have a infinite canvas to draw on. Why I'm not able to properly draw it? This was the sole reason I bought this tablet a year back, but didn't use it. Right now I forgot how to use it, but actually I got the gist of this problem, like how we are solving it. Though I'll try to make this once again. So this is stack, and then this stack we have called with value 3. We have called with value 3. So height 3 we have called, and after calling height 3 we are going to make let's make the functional call tree, right? That would be better. Yeah, so we have called AIGST height 3. this will call this will make one new call. Height 3 I have called. This will make a new call called height 9. So height 9, what it will do, it will make two calls. IGST height null. This will return 0, and once again it will make one more call, removed, and this will return 0 to left height. So current left height will be 0 here, and it will call GIGST height null at line number, this will be called at line number 3, and this will be called at line number 5. So both are called. This will also return 0. So 0. Now what is happening is both of them are called and the difference is not that great. So now it is, I guess, looking much better. So we will add them and we'll try to subtract them, right? So it is not greater than 1, the subtraction, right? So we are not returning -1, and we are proceeding to line number 8. That means 0 plus 1. Max is 0 right now. Yeah, 0 plus 1. And for right side, we'll call this one is now completed. So we'll call GIGST height 20, and height 20 will eventually call the left subtree GIGST height 15. Similarly for 15 we'll be getting 0 and 0 and 1. Okay, that means it will make a call. It will make a GIGST height null, which will return 0. Again, one more call, height null. This will also return 0. Both of them will get popped later on, and this 15 one will also get popped. Let's see, 1 plus 0 plus 1 here as well. Now we'll be calling one more function, that is height 7. So again this will make two more calls, height null, again height null, 0 0 0 and 0, again 0 plus 1. Now when 20 is over, right, so it has made its both call. First one is 15, another one is 7, and it got 1 and 1. So while doing 1 and 1 and its max, so at its head, okay, we will be doing one. We'll be doing max of 0, 0 plus 1, and similarly here as well. 0 comma 0 plus 1, and similarly we'll be doing here as well. Returning 0 comma 0 plus 1. Similarly this return 0 comma 0 plus 1. Now similarly it will do return, I mean max of, max here as well, max, again return max of 1 comma 1 plus 1. Okay, so this will be 2 and this will be 1 as answer. Okay, so we have 2 and 1. Now I have left so here overall at line number here we can see left height ये pop हो गया. Suppose when this pops, okay, when let's represent it in this color. When this pops, we are going to so left see, this is the right height. Okay, so right height at which line number? We are now at line number 6. So we are at line number at line 6. We are doing those things. So I mean when we completely popped from here once before, so we were at line 4. So left height बराबर 1, right height बराबर 2. Now we are at line number 6. So at line number 7 we'll try. At line 7 1 minus 2 ABS should be greater than 1, not satisfied. So we will be returning nothing. Now we have not returned anything, so we are just returning max height. Okay, so we are just returning 1 comma 2 max of 1 comma 2 plus 1, that is 3. So we got the height here 1 comma 2 max of 1 comma 2 plus 1, 3. So now at line 1, at line 1 it's not minus 1, so return true. Yep.